So it's always good to have a few examples of how to solve differential equations, but honestly, we're going to go through and practice so many of the types of integration that we've used up till this point. Here's another example that could be confusing. And, oftentimes I recommend instead of having y prime, think of it or rewrite it as dy over dx. But unfortunately for this problem, there's 1, 2, 3 terms. If I move this to the right, then I still have x's and y's there. If I move this to the left, I still have x's and y's. There's an x and a y in this. So occasionally, just doing the algebra part of it before I integrate the sides, I may have to do something a little tricky. I can put the terms with the y's on one side, and then to clear out the y's, it might be wise to move the y's. Oh wait, that's a little too weird. Let's just distribute out something or factor out. What common terms do we have there? I know I could say 2y, but I'm just going to factor out a nice little y from both terms. So with the y divided out here, now separating is going to be really easy. Once again, take a look at this. Dx is in the denominator. I'm going to have to multiply that over. I want all my x's on the left. And because this is in the numerator, I want all my y's on the right. Something like this. And with the separation just like that, now we can integrate, and they both look like common integrals. The one on the right being a natural log. So that's easy enough, except if you were asked to solve for y here, to get y all by itself, somehow you're going to have to unlog that. Can you unlog? Or do we just do the inverse? Would that be an exponential? Why, yes, I think it would be an exponential. And as a matter of fact, I don't even need the absolute value there anymore because aren't all exponentials positive values? We've cleared the way. We've solved for y. And we only have one trick left up our sleeve for this problem. This is something you'll see in calculus quite a bit. Whenever you see that plus c there, that can be rewritten using basic exponential rules. And this is the form that we'll probably see more often. Because when you're adding powers, that's the same as multiplying by the base times that same power. E to the x squared minus 100x is the same as, multiplied by e to the c is the same as what we had up there. And e to the power of a constant is just going to be yet another constant. There's a good reason for why we do that, and we're going to look at those examples specifically when we look at proportions on the next video. For that next one up there, I want you to take a second. See if you can separate the x's and the y's. It's not as hard as the last one, but it looks confusing. And don't forget, I like to rewrite y prime as dy dx. Gives me that hint. Dx is in the denominator here. If I multiply it across, it'll be in the numerator there. I want all my x's on the right-hand side, all my y's on the left. Now that we've got it split up, take a moment and integrate, and I think you'll find that it's great to integrate like this. Taking those integrals, we got some natural logs brewing up. And by the way, with that 1/2 there, I think we could probably go through and just multiply everything by 2. Times 2, times 2. Wait, what is a constant times 2? Constant. So that remains the same. And if you were trying to solve for y here, it would be a bit messy. This is a great solution to the differential equation. Sometimes they ask for you to solve it for y. So please look carefully at this last little weird tidbit. Oh, I would truly like to make these logs just suddenly disappear, but you realize that I had a plus c here. Is it possible if I have a constant, would the natural log of a constant also be a constant? Could I rewrite the constant as the natural log of c? Why not? It's a weird idea, but it does work. And then I know that when I add logarithms of the same base, I can multiply the c and the 1 plus x squared. Now, if I have exactly one logarithm on each side, now I could go e to the power of each of those on each side, or I could just say, hey, you know what, I'm gonna get rid of the logs on both sides. Essentially, you have one on each side. You can cancel them out using an exponential. By the way, this one part here, there's no absolute value because 1 plus y squared happens to always be positive. That won't always work. So we have a solution, but we need to plug in to find c.